Good morning, and thank you for joining us for the best news today. I'm your host, Chelsea Pompiani. As you know, the purpose of our show is to celebrate the stories that inspire us, and I'm so excited to tell you about today's lineup. Our guests include Best Robotics, a nonprofit organization that delivers a free STEM and workforce development program to students all across the country. You'll get to meet the founders and leaderships as we start the show. And you'll want to stay tuned to meet our second guest, a school teacher and a backyard squirrel who saved our life. We've got a lot of great news for you right after this. I'm back here with Rosemary Mendel, the Executive Director of Best Robotics. Rosemary, thanks so much for joining us today.
Thank you for having me.
Absolutely. So let's get right into it. We know a little bit about the program. You guys do such great work all throughout the country. So tell us a little bit about Best Robotics, who it serves, and what you guys do.
Best Robotics is a nonprofit STEM education program delivered to middle and high school students through the vehicle of a robotics competition. Our program is free to schools, and each year students build a robot. They have 6 weeks to do it in an industry theme. At the end of that 6 weeks, they compete at their local hub. Those are our licensed partners. We have 47 of them in 17 states, and students who win the awards at the local competitions have the opportunity to advance to one of 5 regional championships. Wow. Many of our hubs are aligned and partnered with higher education institutions around the country. These include colleges and universities such as Grove City College near here, our latest hub at Carnegie Mellon University School of Computer Science, and Auburn University, whose team designed our game this year.
Oh, that's fantastic. It seems like a lot of good things ahead as well, which brings me to my next question. Best Robotics is clearly thriving, which must make you feel so impressed and proud of the work that you guys have done. So what's in store for Best Robotics for the next 25 years?
Well, it's truly an honor to be a part of this organization since we are celebrating our silver anniversary this year. And it grew through a very grassroots effort for many years that was all volunteer-based. And now that we have the structure of a staff, a small one, albeit a small one, our goal is to increase our reach of the program. The fact that it's free enables us to reach students in both rural and inner city areas, as well as students in suburbs. We are reaching many minority students. We're reaching more girls than most programs do. And we just want to stay on that track.
So right now we are live reporting on the situation affecting the oceans across the planet. The volume of garbage and plastics have reached critical levels, and they're threatening marine life and the food chain it supports. So right now I'm live with TJ Nguyen, who is of Auburn University's Southeastern Center of Robotics Education. So I believe your team is working on a plan, right, for this?
Garbage is collecting in naturally occurring whirlpools called gyres all over the world. These gyres are really difficult and dangerous to get to, which is why I believe robots are a perfect solution to try to solve this crisis.
All right, thank you, TJ. Now we're going to stay out here as the story is still very much developing, and we'll bring you back out later in the newscast.
We're back. Thanks so much for joining us. 25 years of service is quite an accomplishment for any organization. Best Robotics is a front runner in this field way before we had the acronym STEM and STEAM. Today we have the good fortune to be joined by 2 of Best Robotics founders, Ted Mahler and Steve Marham. Ted, Steve, welcome to the program. Will you tell us a little bit about how you two came together and what really inspired this?
My inspiration for the program actually started back in high school. My friend and I would gather up broken TVs and radios, try to find the parts that worked, and cobble something useful out of what we found. I always got such a great feeling of accomplishment from that. I wanted high school students today to be able to have that same feeling of accomplishment.
Is the program today a lot like you had envisioned it?
Yes and no. Yes, it is, because a kid coming in today from from the very first year we did this, would recognize the event. He would be comfortable within its rules and within the confines of the limitations we give them. They would be okay. But it's gotten more sophisticated over time. The controllers are more sophisticated. They program now. We've added that element. It's a really nice event, and it's a lot of fun.
We are still back out here live with TJ, but Ocean Unite actually gave us some footage that we're going to share with you right now, so let's take a look at this.
The ocean is life itself.
The ocean is in danger.
You may not see it above the surface.
But the threats are many. The risks are real.
Plastics choking our sea life. Pollution causing dead zones.
It's not too late to solve this crisis.
And we have to. We have one planet.
The ocean is very resilient and it can recover.
But it will take more than pictures of melting ice and polar bears.
The world requires a united force for change.
A formidable force for good.
The ocean needs you.
So TJ, you have a plan, like you're working to solve this, right?
After talking to scientists and engineers, the problem is much more dire than we thought. But I believe we have a solution. Using a three-pronged approach of removing the garbage, assessing the wildlife, and attempting to rebuild ocean habitats, I believe we can solve this problem. The situation is much worse than we thought. But we're tapping the best minds in the country. Best robotics students will be taking on the challenge in only 6 weeks. And I brought a little bit of footage to explain how. Welcome to the 2018 Best Robotics Competition Current Events. This year's game is brought to you by the Southeastern Center of Robotics Education at Auburn University. Current events will challenge and test your engineering skills, data analysis, and problem-solving abilities. Current Events is a recycling game played on a 32-foot by 12-foot field. The field is divided into 4 currents designated by 4 unique colors. Currents are unstable rails that are elevated at the starting positions. Robots will be able to ride the current from the starting position, but will have to fight the current headed back. Ocean garbage is the primary type of game piece that will be scored. These include soup cans, 8-ounce, 16-ounce, and 1-liter plastic bottles, microplastics, and rubber duckies. Robots will have to beware of the sea turtles while they're working in the ocean gyres. All game pieces except the rubber duckies will be located on one of 4 ocean gyres. There is an Atlantic Ocean gyre, an Indian Ocean gyre, and 2 Pacific Ocean gyres. 2 rubber duckies will be found on top of each team's current. Ocean garbage can be scored by either of the 2 spotters, the field engineer or the field scientist, in this year's game. The field engineer is located in the field engineer operating area at the end of each team's current. The field engineer can collect garbage from the robot using the recycling box found in the field engineer operating area. The field engineer can use recycled garbage to build reef blocks and filament tubes that the robot can mount onto the artificial reef structure. Each reef block must be made up of 4 of the same type of garbage. Completed reef blocks and filament tubes will be placed on the receiving platforms for the robot to pick up. Field engineers need to be careful to avoid handling the sea turtles. Only field scientists are qualified to handle the wildlife. The field scientist is located in the field scientist operating area to the side of each team's current. The field scientist can collect garbage and wildlife using the wildlife habitat box located in the field scientist operating area. The field scientist is responsible for assessing the impact of the ocean garbage on the wildlife. They will inspect the sea turtles, and any garbage found in the turtle's stomach will be worth double as we try to minimize the damage to the ecosystem. Each field scientist is also responsible for the current flow analysis. The rubber duckies found on each team's current contains information that allow teams to figure out the direction of the current's flow. Chances of determining the correct current flow are increased by collaborating with other field scientists. To determine which robots can be most effective at recycling a variety of garbage types, A flexibility bonus will be given to robots that can score 2 reef blocks with different types of garbage, a reef block and a filament tube, 4 reef blocks with each type of bottle and soup cans, in addition to 1 filament tube. Good luck, Best Robotics teams, as you compete in Current Events 2018. Hello, hello. Can you hear me now? Better? Okay, sound's back on. Welcome to the 25th anniversary game for Best Robotics. Really excited to be here to do the first universal reveal. I'm going to answer some of the questions in the chat. Post your comments there. Make sure you attend your Hub's kickoff event to get all the details about this year's game. It'll be your chance to see the field and get the complete rules and drawings. Those will be available on the BRA website after this. The time limit is still 3 minutes. David Cossey. The video and game animation will both be available on our website immediately following this. Gauge, robots are clamped onto the current and will roll along the rail. We will have a rail at compliance, and it will be inspected to make sure it's safe, similar to what we did at Warp 2020. All robots are on the rail for the entirety of the game, Pacey. So each robot has their own rail to ride on. Note, the robot is exclusively on the rail, and it's actually limited to exclusively on the rail. The dimensions and things like that will be in the full field drawings. So the turtles are accessible from each half, and 2 teams can get each turtle, but all turtles have the same bonus inside of them per match. You have to wait until your hub kickoff to start on the design. There are 2 spotters in this game. The field scientists are located close enough to each other to collaborate, and the scientists can talk to each other as engineers, and then they can go, you can either yell across the field or communicate in a chain. There are no team turtles. They are in the communal centers. Yes, the trash inside the turtle gauge is a bonus multiplier, and the trash in the turtle changes per match. Risner, the reason I wanted to have 2 spotters this year is to focus on how scientists and engineers work together in the real world. This is best boosting engineering, science, and technology. So science has typically been in the background of a lot of our engineering games, and so I wanted to show that the two complement each other. Let's see. All the game pieces are grabbed by the robot. The incentive to collaborate with other field scientists is to get more information. So each ducky only has a number per color, and that's explained more in the rules. Stuart, the tube with the ping pong balls in it, they're actually hollow golf balls recycled from last year's game. They are called filament tubes, and they are used for the artificial reef. Okay. Won't the ducks get in the way of the robots? Yes, they are meant to, and they can be knocked off with the robot or grabbed with the robot. The robots will be checked to make sure they don't fall off. What if the robots falls off? They'll be checked at compliance to ensure that doesn't happen. Tiger Stripes wants to know, the current confuses me. How is that determined, and what do the numbers mean? I believe you're talking about the current flow analysis. I would look at the rules for a detailed explanation of that. But essentially, by collaborating with other scientists, you can guess one of 24 combinations. Codster, what is the weight limit? They are the general best spec limits. Let's see. The hub fields available are the hub fields available for practice during the 6-week build session. So you will be able to see the actual field at kickoff, and you'll be able to see it at your school or your hub's mall day. What are the combinations about? So the combinations of different reef blocks and filament tubes are all about showing how versatile and robust your robot is at cleaning different kinds of trash. Where do we put the trash? On the shelf or in the box? Garbage can be recycled either in a box, but you get more points by putting it in a box on the shelf. Can you explain the instability of the rail? So the current rail is a beam. On one end, it has a spring to add some up and down motion, and then on the other end is suspended by a rope, so it also swings side to side to simulate the ocean's surface. So one side is higher than the other to simulate riding the current in and then fighting the current back. When will the point values be released? They will be available immediately after the stream in the complete game rules. Does the robot need to be waterproof? There is no actual water in this year's game. It's just a water-themed game. Charlie Randall wants to know, how will the robots be mounted onto the rail? That is up to teams to figure out how to design. Similar to Rad to the Core or Warped XX, I'm just taking the robot off the ground. Let's see. How does the current change? So I assume NPU is referring to the current flow analysis, and that changes on a round by round basis, just like the trash in the turtle's stomach. David Cossey wants to know how much a field costs, and the BOM and field drawings are available immediately after the stream. Oliver wants to know, what are the turtles made of? And I'm excited to announce that the sea turtles are the first 3D printed game piece in Best Robotics. So 1 pilot and 2 spotters. So yes, there is 1 driver and 2 spotters. They are the field engineer and the field scientist. Truman wants to know, are the different oceans points weighted differently? And they are not. The different ocean gyres are just where different game pieces are located, and they're located at different heights to increase the challenge from the rail. Let's see. The 3D, are we going to get the 3D files for the sea turtles? Yes, those will be available immediately after the stream. Does the rail move? Yes, the rail is moving and unstable. Are the bottles going to be together in a box that we have to pick up separately, or will the bottles be individually scattered? So the game is reset by putting all of the garbage on each gyre randomly onto the gyre. Let's see. The engineer and scientist, will the engineer and scientist have to pass the controller to each other? There is only 1 driver, and neither of them is the engineer or scientist, so they will not touch the controller. Where does the robot start? The robot starts at the high end of the rail and will ride the rail into or downstream. Will there be a recording of the stream for us to review later? Yes, this will be available, as well as the game video and game animation. Do robots have to put pieces into buckets before the driver and spotter can touch them? Yes, so the driver and spotter both have a box at their disposal to catch game pieces from the robot. Elaborate on the spotter's role, please. So there's 2 spotters in this year's game. The field engineer is focused on building reef blocks and filament tubes for the artificial reef structure. The field scientist is responsible for the data analysis portion of the game, and that includes inspecting the wildlife to see what garbage they've been eating, and so you can minimize the impact on the ecosystem, and then also using the duckies to figure out the ocean's current, and that is a gameplay element based on a barge of sea duckies falling over in the Pacific Ocean, and then scientists used the duckies showing up all over the world to actually calculate ocean currents. All right, I think questions are slowing down. Is there any way to lose points or get a penalty? There are the regular penalties in the general, the best generic rules. There are no ways to lose points. Can the scientist give garbage to the engineer? The scientist cannot pass anything to the engineer. So if the scientist collects garbage, it is scored at the lowest rate, unless the sea turtle is gained. What is the limit of reach of the spotters for picking up the resources from the robot? The field scientist will have a 36-inch net and a wildlife habitat box, which is a banker's box, so however long a banker's box is, and the field engineer will also have a banker's box. Can the spotters handle the boxes? The spotters cannot handle the reef blocks or the filament tubes. How do we obtain a turtle if the robot cannot touch it? The turtle can be touched by the robot. The field engineer cannot score or inspect the turtle. So if the robot brings the turtle to the field engineer, it will not be scored and there will be no bonus. So what is the policy on starting prototyping early since we have all the game information? The policy is to wait until your hubs kick off. Can the field engineer interact with the field scientist? The field engineer's only interaction with the field scientist is verbal or visual. They cannot pass things to one another. How many comments for me to shave my head? My head used to be shaved, so that'd be like a Control Z type action, and I don't really want to do that. Let's see. Will the dimensions of the turtle be made available? The STL for the turtle and the turtle cap will be available. Best, how long will the challenges be? Best matches are 3 minutes long. Are the turtles sized similar to a house turtle or more of a some other kind of turtle? I am not familiar enough with turtles to identify what kind of turtle it is. I did modify the model of a Mario Kart turtle to make this year's turtle. Can the robots interact with other robots? So the most interactions robots can have with one another are through the passive spinning of the gyres. So those are on Lazy Susans and can spin with a garbage on it. And and if it's possible for them to reach across to the same gyre, they can interact. But that seems unlikely to me. Is it the engineer or the robot that assembles the reef blocks? The field engineer assembles the reef blocks and the filament tubes and places them on a shelf for the robot to then grab and score. Is the motion of the beam influenced by anything other than the robot's movement? No. What happens if you drop trash? The rules for dropping trash are in the rules. So you'll see that when you go through. Does each team have their own locations to retrieve their own materials, or is it a race to get all the materials? Robots really only have access to one half of the field's materials. Can the spotter grab the garbage from the robot, or must the robot drop it? The robot has to drop it. There could be no touching of the spotter and the robot. I noticed on the rail there were holes. Is there any significance to this, or was that just something that is there? Pacey, that's how the rails are constructed. So they're bolted together, and they are used for magnets to hold the duckies in place, and then there will also be a starting pin, a safety pin to hold the robot before it starts. Similar to last year's competition, will modifications during the game be allowed? Mark? No, not this year. There will not be modifications in game. Let's see. How high are the rails off the ground? Virginia, they are in the field drawings, but it is, I don't know, a good height. After the engineer fills the reef blocks, how are they expected to elevate them onto the scoring platform? There is a platform between the scoring platform and the robot called a receiving platform, Jaden, and the field engineer can set the reef blocks and the filament tubes on there, and then the robot grabs them from there. If you need 3D printed turtles made, you can contact SCORE, and we would be happy to get you turtles. Jakirion, are there any new materials in the kit this year? You'll have to check the rules. David Walker, can the robot move independently, or is it entirely dependent on the current? So it is up to the robot to move along the current. The current only responds to the field. until the robot's movement. David, so there's a station that gives you trash and gives it tubes that the robots then puts on shelves. So David, in the field engineer's operating area, there are boxes that the field engineer can fill, and then they can put those boxes on the shelf for the robots to put on the scoring shelves. Shelly wants to know what inspired my vision for the game. So 14 years ago was my first Best Robotics, and I've always wanted to design a game, and I wanted to design a game that focused on engineers and scientists, and I wanted it to be a problem that everybody can relate to. And I think everybody's seen images of the Great Pacific Garbage Patch. I think everybody's been to a creek or a body of water, and they just see how much waste and pollution we put out there as people. And I don't know, I thought it was a cool challenge. What happens if the robot falls off? So that question keeps getting asked, and I'll answer it again. But the robots will be tested for safety at compliance. There is a compliance structure that you can mount your robot to, and the compliance crew will make sure that it is safe. Can we manually anchor the robot on the rail, or is it expected to anchor itself? The game will be similar. The game will be similar to a Warped XX, where there will be a setup period, and teams will be able to mount their robot to the rail. Is the robot able to hold multiple objects at once? Yes, that is up to the robot. Can the robot be suspended on or below the current? So the robot's max height is 8 inches above the rail. So the dimensions of the robot are still 24 inches by 24 inches by 24 inches, but the maximum dimension can be no more than 8 inches above the rail. Are there tracks on the rail for the robot? There are not tracks. Do the baskets spin? Yes, the gyres are all on Lazy Susans, and so they all spin. But they spin passively, so they would only spin from input from one of the robots. Words Torp Gaming, we have no 3D printer. How can we obtain a turtle? There's different 3D printing services, and you can contact us at scoreau.org, and we can help set you up with a turtle as well. How long is the setup period? It should be in the rules. Can you knock off other robots? You would not be able to reach other robots, and that is also against Spirit of Best and the generic rules. Jakirion. Just to clarify, the robot were able to dump a bunch of trash into the spotter's box. The spotter can pick it up and organize it while the robot goes for more game pieces. That is correct. Are all the turtles green? The turtle colors are up to the individual hubs. How big are the ducks? The ducks are available in the BOM, and you should be able to find them and buy them. Are the game pieces stable in dimensions and weight, or are they variable? So since this is a recycling game, I wanted to make sure that we were able to use recycled pieces. So all bottles and soup cans on the field can be recycled, so they can vary. They will be the same for fields, and then the limiting criteria for which recycled materials you can use is, does it fit in the reef blocks? How far are robots allowed to hang under the rails? The robots have no minimum or no maximum to hang under the rail. It's only a maximum of 8 inches above the rail. Will the magnets be strong enough to stop the robot? No. Do you get extra points for obtaining the rubber duckies? So rubber duckies are scored like trash, but they give you information to score more points. Is there any significance to the colors of the trash, Adam? There is no significance other than it will help reset the field. So they will be colored as to which gyre. Rail dimensions will be available on the generic in the field drawings. How many custom parts can we make? That's also in the rules. Is there any limitations on orientation of the robot? As engineers, you set your own coordinate system, so it can be upside down or right side up. It just depends on which way you're looking at it. Are we allowed to anchor our robot? I'm not sure exactly what you mean by anchoring your robot. What do you mean you can't modify the robot? In last year's game, you were allowed to dock and then add and change modifications to your robot, and so I believe somebody was asking if we are still allowed to do that. Can the robot extend downward or upwards after the round starts? Yes, that's in the rules. Can an arm stick up over 8 inches after starting a round? Yes, they can. Can you score without a box full of trash? So the reef blocks are bonus scores. You can score garbage for lower amounts of points just by putting it in the field engineer's box. Is it still 24 by 24? No, this year's game is long and skinny. I believe it's 32 by 12. Will there be leftover materials in the water bottles, such to make them uneven or weighted? No, there will be empty water bottles and empty soup cans. All right, can robots make contact with the floor? Yes, robots can pick up objects off the floor if they fall. How are the items in the turtles? The items in the turtles will be laminated pieces of paper that will indicate which turtle is on there. Tiger stripes, only 8 inches above the rail. Yes, the rest of the robot has to be under the rail. All right, I think I'm getting ready to get off. Let's make sure we're using our hashtags for this year's game to celebrate the 25th anniversary. Thanks to Best Robotics. And I'd like to thank our 25th anniversary sponsors, Texas Instruments, and our national sponsor, MathWorks. So everything else you can find in the rules and the Q&A. But thanks for tuning in, guys.